Hi guys, welcome back. Today we're going to be moving on to factorising. So I'm going to begin with the question of what is x plus 2 multiplied by 2x minus 3 equal to? So to find out the answer, we can multiply the two brackets and we'll end up with 2x squared minus 3x plus 4x minus 6. This can then be simplified to 2x squared plus x minus 6. So we found this answer by the process which is known as expanding out brackets, and factorising is the reverse of this process. So now you can imagine that a factorising question might start out with 2x squared plus x minus 6, and the answer would be x plus 2 multiplied by 2x minus 3. And in this video, I'm going to explain the first method of factorising, which is known as taking out common terms. So the first question asks us to factorise 2x squared minus 4xy. So in order to factorise by taking out common terms, we must divide the expression by the highest common factor. In my video on natural numbers, I explained that the highest common factor is the largest number that would divide into both numbers, leaving no remainder. So therefore, we can see that 2x is the highest common factor of the two numbers 2x squared and 4xy. In order to factorise 2x out of the expression, we have to divide 2x squared and 4xy by 2x. So here we can see that we've taken 2x outside of the brackets, and in order to compensate for this, we have to divide 2x squared by 2x and 4xy by 2x. We are effectively multiplying and dividing the expression by 2x. And we know that if we multiply and divide any number by the same number, we end up with the original number. So in this case, we have taken the 2x outside of the brackets without changing the actual expression that we started off with. This is because 2x divided by 2x is equal to 1, and multiplying any number by 1 gives you back the original number. Now that we have 2x factorised outside of the brackets, we can simplify the inside of the brackets. According to the rules of indices, which I covered a couple of videos back, 2x squared divided by 2x is equal to x, and minus 4xy divided by 2x is equal to minus 2y. Now if you're unsure about the rules of indices, you should definitely check that video out. Now we can check our answer. Remember that we said that factorising is the reverse process of expanding out brackets. So if we expand out our answer by multiplying 2x by x and 2x by minus 2y, we are left with 2x squared minus 4xy, which tells us that we are correct, because that was the original expression we started out with. So for the second example, we are asked to factorise 4x squared y plus xy minus 3xy squared. Now in this example, we have 3 terms instead of 2. So to begin, we find the highest common factor between each term in the expression. In this case, the highest common factor between all 3 terms in the expression is xy, since xy is the highest factor which is common to all 3 terms within the expression. So using the rules of indices, which I mentioned in the previous video, we can divide each term by xy and then multiply the whole expression by xy. So by doing this, we have taken xy out of the expression without actually changing the value of the expression. This is because, as I explained in the first example, if we divide each term by xy and then multiply each term by xy, we haven't changed the value of the expression because xy divided by xy is equal to 1. And multiplying any number by 1 gives you the original number back. So all that we're doing when factorising is rearranging the original expression so that we have the highest common factor on the outside of the brackets. And if you want to check your answer, like the first example, you can expand out the brackets by multiplying xy by 4x, xy by minus 3y, and xy by 1. And you should arrive at the original expression. This is a very good way to check your answer to make sure that you've factorised correctly. The difference between grouping and taking out common terms is that with grouping, we have to split the expression into two halves and then take out common terms. Sometimes the expression won't be written in the correct order, so you will have to reorder the expression in order to be able to take out common terms on both sides. Grouping is used when we have four terms with no common factor between them all. Remembering from the previous section that the highest common factor is the largest value that will divide into each term evenly in the expression. So just like I explained in the previous section on how to factorize by taking out common terms, we have to take the highest common factor of both terms outside of the expression. So we look at the first half of the expression, 2xy minus 6x squared y, and we can see that the highest common factor of both numbers is 2xy. So by taking 2xy outside of the brackets, we divide each term in the expression, 2xy minus 6x squared y, by 2xy. If this technique of factorization confuses you, you could go back to the previous section where I explained how to factorize by taking out common terms. Grouping is very similar as it works with the same principles as taking out common terms. There's just some extra steps involved. Now looking at the second half of the expression, x minus 3x squared, we can take the highest common factor, x, outside of the expression and then divide each term of the expression by the highest common factor. So taking a look at the first set of brackets, 2xy divided by 2xy is equal to 1, and minus 6x squared y divided by 2xy is equal to minus 3x. Having a look at the second set of brackets, x divided by x is equal to 1, and minus 3x squared divided by x is equal to minus 3x. At this part of the process, you will know that you are correct if the two terms inside each of the brackets are equal. So in this case we're correct, as we have 1 minus 3x for both brackets. Since 2xy and x are both being multiplied by 1 minus 3x, we can group them into the same bracket. This is because, if you remember from my previous section on how to factorize by taking out common terms, I explained factorizing as the reverse process of expanding out brackets. And by expanding out the brackets 2xy plus x multiplied by 1 minus 3x, you will end up with the previous line. So because of this, we have factorized by grouping, and we have ended up with our answer 2xy plus x multiplied by 1 minus 3x. And if you want to check your answer, you can multiply out the two brackets and you should end up with the very first line of the question. So for the second example, we have 6x squared minus 2y minus 12xy plus x. We can factorize the expression by grouping, by rewriting the expression as 6x squared plus x minus 2y minus 12xy. Taking a look at the first half of the expression, 6x squared plus x, we can take out the common factor x between both of these terms. In order to cancel out this multiplication by x, we must divide each term of the expression by x. This ensures that we haven't actually changed the value of the expression that we're dealing with. Looking at the second half of the expression, minus 2y is the highest common factor of minus 2y minus 12xy. So just like what we did before, we can multiply and divide each term of the expression by 2y. Taking a look at the first set of brackets, we can say that 6x squared divided by x is 6x, and x divided by x is 1. Taking a look at the second set of brackets, we can say that 2y divided by 2y is 1, and 12xy divided by 2y is 6x. We can see that we're correct, because each bracket contains 1 plus 6x. The order of the numbers in each bracket does not matter. Again, because x and minus 2y are both being multiplied by 1 plus 6x, we can group x and minus 2y into its own bracket. Both lines are equivalent, because if you multiply out the brackets, you will end up with the previous line. So then this leaves us with our answer, x minus 2y multiplied by 1 plus 6x. The difference of two squares is just two squared numbers, such as x squared and y squared, being subtracted from one another. If I multiply x minus y by x plus y, the answer I will get will be x squared plus xy minus xy minus y squared. Here, the plus xy and minus xy add to equal 0. This leaves us with x squared minus y squared. Because of this, we can say that x squared minus y squared is equal to x minus y multiplied by x plus y. This is an example of a difference of two squares, since y squared is being subtracted from x squared. So we can begin by looking at an example. In this case, we have 16x squared minus 4. 16x squared and minus 4 are both perfect squares because we can find their square roots, leaving no remainder. In this case, the square root of 16x squared is 4x, and the square root of 4 is 2. So we can rewrite 16x squared minus 4 as 4x squared minus 2 squared. Because the square root and the square of a term are opposites, we have not changed the expression by doing this. Now that we have our term in this form, we can use our rule. 4x squared minus 2 squared is the same as saying 4x minus 2 multiplied by 4x plus 2. So we have arrived at our answer. If we want to check our answer, we can multiply 4x by 4x, 4x by 2, minus 2 by 4x, and minus 2 by 2. This would leave us with 16x squared plus 8x minus 8x minus 4, which simplifies to 16x squared minus 4. Since factorising is the reverse process of expanding out brackets, 16x squared minus 4 should equal to the original expression that we started off with. And that's how we know that we are correct. For the second example, we have 25x squared minus 49. The square root of 25x squared is 5x, and the square root of 49 is 7. So we can rewrite the expression as 5x squared minus 7 squared. Using our rule, we can rewrite this as 5x minus 7 multiplied by 5x plus 7. So this is our answer. Again, if we want to check our answer, we can multiply out the brackets. Factorising is the reverse process of expanding out brackets. So when we multiply out the two brackets 5x minus 7 by 5x plus 7, we should end up with the original expression. Simplifying out our result, we end up with 25x squared minus 49, which is the same as the original expression. So we know we are correct. A quadratic trinomial is an expression which takes the form ax squared plus bx plus c, where a, b and c are all constants. Knowing how to properly factorise a quadratic trinomial gives us the skills to break down quadratic equations into simple parts. This then gives us the tools to understand the properties of quadratic functions, which describe many phenomena that we see on a daily basis. So we're going to take the example of x squared plus x minus 6. In order to factorise this, I'm going to break it up into 3 different steps. So for step 1, we have to find the factors of the constant inside the quadratic trinomial. The constant is minus 6 in this case. The reason that minus 6 is the constant is because it never changes. Any number being multiplied by a variable, in this case x, does change, because x can take any value. So we can list out the factors of minus 6. So if we multiply minus 1 by 6, we get minus 6. In the same way, if we multiply 1 by minus 6, we get minus 6. If we multiply minus 2 by 3, or 2 by minus 3, we also get minus 6. So here we have listed all of the factors that make up the constant of the quadratic trinomial. So for step 2, we have to find which factors add to equal the value of the coefficient of the x term. So what does that actually mean? Well, the coefficient of x is just 1 in this case. A coefficient is defined as a constant being multiplied by a variable. So in this case, we just have x or 1x. So the constant is 1. And so therefore, the coefficient of x is equal to 1. So we can see that if we add minus 1 and 6, we get 5. If we add 1 and minus 6, we get minus 5. If we add minus 2 and 3, we get 1. And if we add 2 and minus 3, we get minus 1. So you can see that minus 2 and 3 both add to equal to 1. which is the coefficient of the x term in the quadratic trinomial. So for step 3, we then take these factors and we insert them into the brackets as shown. We end up with x minus 2 multiplied by x plus 3. So this is our answer. This is the factorized quadratic trinomial. So we've essentially turned a trinomial expression into two binomial expressions, where bi refers to 2 and nomial refers to terms. So a binomial expression is an expression containing two terms. As you might have seen in the previous factorizing videos, we can check our answer by multiplying out the brackets that we end up with. So multiplying out x minus 2 by x plus 3, we get x squared plus 3x minus 2x minus 6. And we can simplify this to x squared plus x minus 6, which is the original quadratic trinomial that we started off with. So again, the reason that we can check our answer is because factorizing is the reverse process of expanding out brackets. So when we multiplied out x minus 2 by x plus 3 and got x squared plus x minus 6, factorizing is the opposite of that process. So by factorizing, we have turned x squared plus x minus 6 into x minus 2 multiplied by x plus 3. So thank you for watching this video. In the next video, I'll show you how to solve a quadratic trinomial in which the coefficient of the x squared term is not equal to 1. Whenever the x squared term has a coefficient that isn't equal to 1, we have to deal with the quadratic trinomial slightly differently. So today I'm going to extend the idea of the previous video, where we factorized a quadratic trinomial where the coefficient of the x squared term was 1. So I'm going to extend this discussion to quadratic trinomials which have x squared terms with coefficients which are not equal to 1. So in this case, the coefficient of the x squared term is 2. Now, if you haven't watched the previous video about quadratic trinomials, I suggest you go back to that one. So we begin with the same method of finding the factors of the constant of the trinomial. In this case, the constant is minus 15. However, we have to find the factors of the constant multiplied by the coefficient of the x squared term. The reason we didn't have to do this in the first example was because the coefficient of the x squared term was 1. So when we multiplied the constant by 1, we ended up with the same number. The factors of minus 30 are 1 and minus 30, minus 1 and 30, 2 and minus 15, minus 2 and 15, 3 and minus 10, minus 3 and 10, 6 and minus 5, and minus 6 and 5. So like the previous video, now we have to find which factors add to equal to the value of the coefficient of the x term of the quadratic trinomial. So by trying each possibility, we see that if we multiply minus 6 and 5, we get minus 30. And if we add minus 6 and 5, we get minus 1. We can see that minus 1 is equal to the coefficient of the x term in the trinomial. So now we can replace the x term of the quadratic trinomial with each factor being multiplied by x. So by doing this, we end up with 2x squared minus 6x plus 5x minus 15. From this point on, we then have to factorize by grouping. If you don't know how to do this yet, you can watch my previous video where I cover this in detail. So we take 2x as the highest common factor of 2x squared and minus 6x. And 5 as the highest common factor of 5x and minus 15. Then rearranging our grouped expression, we end up with 2x plus 5 multiplied by x minus 3. And this is our answer. So by putting everything together, we ended up with two binomial expressions that represented the trinomial expression that we started off with. As always, we can then multiply out the brackets to check our answer to see if we're correct. Multiplying these brackets out and simplifying, we end up with 2x squared minus x minus 15. So we have proved that factorizing 2x squared minus x minus 15 leaves us with 2x plus 5 multiplied by x minus 3. And as I always say, this is because factorizing is the reverse process of expanding out brackets. So if we re-expand out these brackets, we should end up with the original trinomial that we started off with. So when the coefficient of the x squared term of a quadratic trinomial is not equal to 1, you can use this method. If you enjoy my videos and want to support me, please consider liking the video and subscribing to my channel. And if you want to see more videos like this one, please consider checking out the playlist section of my channel. Thanks for watching, and I'll see you in the next one.